All right, we're on the air. Hi, everybody. Welcome to the first episode ever of Designated Driver, the casual happy hour-ish or happy half-hour-ish podcast where we have a beer or whatever other beverage of choice with our special guest from a different database community on every episode. Um, let's go around and maybe just do some the self introductions. We can introduce ourselves and perhaps introduce the beer or other beverage we're having today. I'll go ahead and go first. My name is Evan Rusakis. I'm a PMC member on the Apache Superset project and a developer advocate for Preset. I also have a long-standing interest in beer. I'm a nationally certified beer judge and just beer nerd all around. And to introduce my beer of the day, since we have a guest from CelerData, I thought I would try to find something relevant. So I picked something from my cellar, which I used to keep data about, thus Cellar. I used to have a spreadsheet of all my cellared beers. So this is a Belgian quad beer from a Trappist brewery called Spencer that went out of business. I guess the business model didn't pan out for the monks. So this is the last of them.
Wow.
But anyway, that's me. I'll pass the mic over to Beto.
Yeah, I'm Beto. I'm a software engineer at Preset. I've been working with Superset for 6+ years, since 2017. I do a lot of the database integrations. So I wrote like SQL Alchemy drivers for Druid, for Pinot, for Google Sheets, for a lot of stuff. So this is really fascinating to me, just understanding different databases, how they work, and how we can like visualize their data. I'm in Florida. I moved here 2 days ago, and the beer I chose is not from Florida. I'm pretty sure this is from the West Coast. Evan would know.
Oh yeah, Elysian.
So this is the Space Dust IPA. Since we're going to be talking about StarRocks, I thought, well, StarRocks, they have space dust on them.
Cool.
And with that, I'll pass it on to our guest, Albert.
Hey guys, I'm Albert Wong. I'm the developer advocate at CelerData. So formerly Red Hat, formerly MongoDB, and then now at CelerData. So CelerData, we build a product called StarRocks. It's a Linux Foundation project. It's an OLAP database. So we play in the same spaces as Snowflake, Redshift, BigQuery, and the like. So as a Linux Foundation project, you kind of know that you give up your trademarks, right? So to the Linux Foundation, right? So we can't call the company itself StarRocks anymore. We originally did. And then, so it's called CelerData, which is Latin for celer, means quick. So it's like quick data. That's how we got our name. Yeah, that's the company. And today's beer I have is a SoCal favorite, Green Cheek. I don't know, Evan. Do you know these guys?
I've heard of them, and I've looked them up, and I looked up that beer too. Actually, it's a milkshake IPA, which is a whole interesting thing. We'll talk about that.
Yeah. So these guys are one of the best IPAs in Southern California, right? So I was joking with Evan because if you're a Northern Cal person, you're usually like a Racer 5 guy, right? Because that's like an old school, right? And for SoCal, there's a bunch of breweries, right? But this is one of the older ones, right? They got 2 locations, and they have a lot of interesting different IPAs, right? So, but Cocoa Hut, I thought it would be a little bit different. It's tropical, and you don't see. I mean, how many coconut-based beers do you see, right?
Yeah.
Yeah, maybe like porters and stouts, perhaps, but not too many in an IPA. That's interesting. Yeah. Well, cheers. Thanks. Welcome. And I've got more questions, but first things first. Salud.
Saúde.
So, I guess, I'm tempted to dive into the topic of a milkshake IPA. Maybe we'll follow up on the beer later once you've had a few sips and see how it is. But I'm kind of curious to hear a little bit about your origin story, both like, why and how StarRocks and CelerData kind of came into the universe. What was the moment where somebody woke up in the middle of the night and said, this needs to be a thing? And, how did you get involved in that project?
Yeah, so actually, we're a fork of another project. So Apache Doris, if you're familiar with them, right?
Mm-hmm.
And so our founders wanted to fork Apache Doris for many reasons. They wanted a CVO, they wanted a different vectorized search engine. They also thought that the idea of a data lake house was the future. Like 5 years from now, everything will converge to a data lake house, right? So for people who are not familiar with that concept, traditionally it's always been two kind of ideas of long-term data storage, right? So everything that's curated, managed, that's in the data warehouse, right? It evokes this image of like Indiana Jones, and I've got I've got the ark, and I'm gonna take it on in, and I'm gonna like do some data cleansing, and we're gonna do some category management. And the lone guy in there, it's like us, the data engineer, the lone guy is pushing it into the warehouse, and we're gonna push it out, and it's going to be available to everybody who wants it, right? And so that's always been the data warehouse, and maybe like I would say like 5% or even less of all the data that's actually generated by your company actually goes in the data warehouse, right? It's like KPIs, everything that really managed, and everything else, structured, unstructured, was thrown into the data lake. And when you ask people what a data lake is, some people think it's like a bunch of hard drives that they store long term in. Maybe somebody's a little bit more sophisticated and they'll put it on Hadoop, on Hive, right? And then the newer generation is like, we're going to put, say, for instance, Parquet files on S3, right? And the idea was like, well, why do these two worlds have to be different, right? Why can't they just be the same thing? Because you want to get value from your current data and historical data. So why can't you build a quote unquote data warehouse features on top of the data lake so that you get things like materialized views, you get sub-second response times, you get all the things that you were kind of like promised, with this whole new age of data and the idea of elastic capabilities and whatnot, right? So anyways, like most open source projects, the founders kind of like said, we want to go this way. The project didn't want to go that way, and then said, okay, we're going to fork it, right? And so the fork became StarRocks. 90% of the code base got rewritten. And so if you see some of the things that we've done, like our claim to fame here is like, really fast on joins at scale. So we're talking about, we have like a community user that's like 10 petabytes. They're using Apache Iceberg, and ad hoc queries are less than 2 seconds across anything, across all that 10 petabytes of data, right? We also support Hoodie, Delta Lake, Apache Hive, Pymon, right? And so we got that. The other thing we're really good at is separation of compute and storage. So you can have, is basically the same as the Snowflake BigQuery architecture. We also support the Redshift architecture, which is kind of like where the storage and compute is co-located. So both models, right? And so as with any open source project, we all the source code is available on GitHub. We do have a commercial offering, a managed offering. There are some components that are not available in the open source versions, mainly all around is security. So if you're talking about like encryption at rest, things like of that nature, right? Like they are not in the community version, but we're not gatekeeping. You can do all the materialized views you want. You can deploy as many as you want, and we actively encourage it, right? We think that there's a lot of value to like, this is an area like OLAP database is not an area that most people have spent open source time in, right? So we think it's an exciting thing to do.
Can I ask a follow-up question? Like, how do you manage the features that you provide in the commercial offering? Like, how do you implement them? Are they like plugins? Do you have an encryption plugin, or is it a different code base?
It's not a different code base. It's basically, as far as I know, it's shims, right? So
Mm-hmm.
the shims are just, there as stubs, and there is no code that it just basically calls empty code, right?
Mm-hmm.
And I think this is a larger picture of just like our monetization model is very similar to other open source projects, right? So when I was at Mongo, we
Mm-hmm.
always used an acronym called MOAB for commercialization, which is M for monitoring, O for optimization, A for um, automation, and B for backup. So if any of those features fell into those categories, we
Mm-hmm.
would go and say that's going to be an enterprise feature. Now we've kind of
Interesting.
added it over time, so it's Moab SS, and the extra S was security features, and the other S was support, right? So the idea
Mm-hmm.
here is like any of those 6 categories, right? The idea here is like why would a community customer need is like enterprise like specialty backup or security features, right? They're
Mm-hmm.
like, if you're an open source project, right, you wouldn't need any of those type of things, right?
Yeah.
That was the argument, right?
Yeah.
So I think a lot of open source companies also like run from a similar acronym, right?
And it must be hard. You find a really good acronym, and then somebody says, "What about security?" And you're like, "No, but we already have the acronym. We can't." And then eventually there's two S's, and then you're like, "Fine, let's change the acronym." And
Yeah, definitely. There's always it's kind of interesting, we always have like, we're very inventive, right?
mm-hmm.
Everybody's built on top of other things, right? And
Mm-hmm.
other people told me, or like if you look at the history lesson, like, you know, data warehouses came in the 1990s, right? And then the idea that came on out was just like, you know, Hadoop for more of long-term storage. Spark came on out as a better way for you to go and do, processing from that standpoint. Trino came on out to go and basically beat Spark, right? I mean, it's this competition that evolves just like Moab, and then you got the extra S, and then you got the
Yeah.
extra S, and nowadays it's just, the expectations from the community is like you got to have everything that was like in legacy, right? Plus all these other benefits,
Yeah.
right?
Yeah. Yeah.
And it's tough because it's like there's a lot of engineering that has to happen, and there's a lot of like technical debt that
Mm-hmm.
gets dragged with it.
Yeah. And that goes to a question I have. You mentioned you like that when you did the fork from Doris, I think 98% of the code was rewritten from
90%, yes.
scratch. I think my internet is a bit bad, but like you mentioned, 98% of the code was written from scratch. Is that because you're using a different language, or just like different paradigms, or what was the reason for such a big rewrite?
So I think it's a lot of it was the core understanding of the product itself, or the core thinking around it, right? And so there are some like architectural concepts that the founders really like they emulated the MySQL wire protocol,
Mm-hmm.
and so they wanted to keep that as that, and the way that the framework worked was very nicely designed, and the architecture where there's only like 2 layers of nodes. There's a front end node that does the MySQL emulation, and then there's the storage nodes that persist and read the data from S3 buckets, for instance,
Mm-hmm.
right? So they liked a lot of that, but the problem is that when you look at what you're going to highly optimize for, that the problem becomes is that you're looking at it as like, well, I really need to change some of the fundamental building blocks of the application too. And we get this comment all the time of like all of us build software, right? We all work at companies that build software, and once you get picked an architectural decision, it's
Mm-hmm.
really tough, 3 versions later, 4 versions later, to go and say, like, I really didn't like, or we need to really restructure the base, but it's going to change our entire code base if we do it. And
Yeah.
it's very risky, and we don't have all the test cases. and it's just easy for you to just launch a separate new product
Yeah.
and kind of like have them side by side to see who will duke it on out. And then people are looking at you guys are ludicrous. Why do you want to have two separate development teams, two separate this? And you're like going, well, like that's the thing. The new generation has all these cool features, but we had to go and basically, basically tear down the house down back to studs and rebuilt it back on up. So and that's why if you look at some of the things, the decisions we make, so I can talk about all these great features in the product, whatnot, but there's a benchmark on out there called ClickHouse, ClickBench, right? So ClickHouse built as a benchmarking tool from that standpoint, and you can see Apache Doris, which is the commercial version of SelectDB, and for the same queries, you can see there's a drastic difference in response times. Right, so people say we're exactly the same. And I'm like, well, if we're exactly the same, we should be not that far difference, maybe like 5% difference, 10% difference. But in certain situations, we're like 50% faster, or even 2x faster, right? And those are some of the decisions that we made to go and get that. I mean, and that's the thing is like, it's very, very tough. You ask any of us, and I think so. The listeners on this call would say the same thing. It's like, well, that was the best choice at the time. Would I make the same choice again? It's like hindsight's 2020, right?
Yeah.
Curious about one of the other decisions that was made there along the road, which is when you forked, you mentioned you forked from an Apache project, but you're currently a Linux Foundation project. And I'm curious what went into that decision, or what were the, logistics and licensing gymnastics that entailed?
I had the same question.
Yeah. So that was a little bit before my time. So we're actually Apache 2 licensed, but we're part of the Linux Foundation projects, right? And I think one of the reasons why we wanted to go do that was that we're on the roadmap for CNCF, right? We want to be a CNCF project, and it felt like it was easier to be a Linux Foundation project to move towards CNCF.
Sorry, what is CNCF?
Cloud Native Cloud Foundation.
Okay.
Cloud Native Computing.
Cloud Native Computing Foundation, right? So that's where Kubernetes is based. That's where Containerd is based. Cryo, a bunch of Kubernetes projects are all there, right? And the idea is that they're all cloud native. And we were kind of like, the idea is that there's a lot of databases out there that are traditionally built on VMs, and they just do enough to get you to make it work in a container, but they're really still a VM-based app, right? And then we like to think of ourselves as rebuilt for the cloud. Like our typical model is containers that we throw it on. We give you an operator, and it's not just the operator that you could just install. We actually do some of the automation, some of the higher capabilities that you expect from a cloud native project, right? And so this is kind of the growth that we want to go do, and that's why we adopted separation of compute and storage. And for people who are not familiar in the database world, or people who are listeners from not database world, they probably think we're kind of like crazy from that standpoint. Like, for the longest time, when you had the engine that did your database queries, there would be local disk attached to it, right? That was, or a SAN disk that was attached to it, right? And I think so. Snowflake was the first company that came out with this concept, right, of being rebuilt for the internet. And so they built the idea of saying the compute is elastic, and essentially it's stateless, and the storage layer is also elastic. So the idea here is that you can elastically scale each tier independently. So you can have 20 front-end nodes doing the querying, but only 5 nodes and storage on the back end, right? Or the reverse could be, 3 front-end nodes with, 10, 20 back-end nodes from that standpoint, because you have a lot of data, but not that many client requests, right? And this kind of idea, for the people who are on AWS and Redshift, you guys know this. It's like if you want to expand scale, you have to it's all like this is the building block. This is the VM that you get with the storage, and you got to go like every single one built sideways exactly the same. And you're like, well, why can't it be decoupled? Well, it's because it's designed that way, right? So I always thought it's kind of funny, and maybe it's for them. Like the app guys are always like, it's like aren't you guys always stateless? Aren't you guys always like, what do you mean you guys have all the state? I was like, we're the state part of your application. At some point, have state, right?
Yeah.
You can be stateless all you want, right?
I guess nobody wants to be stateful, right? So now you're like delegating it further down. You're like, okay, we're going to be like stateless computation in nodes, and then storage is going to be elsewhere.
Yeah, I mean, you can also make an argument that theoretically, we're all talking about data structures. And if you ask, hardcore computer science people, they're like going, why can't state just be, why does it have to be SQL, right? Why does it have to why do we have to persist onto that, right? With I remember a time when it was like the 1990s, and I don't know if you guys remember like object databases. Do you remember, guys? Remember this?
Yeah.
Object data, the new guys don't get this. They don't get any of this, right? So it dates yourself, right?
Yeah.
And so you're like, the idea is like you instantiate as an object, and it would just serialize in memory. And somehow it serializes to disk. And you just look at everything as objects, and you don't have this translation layer and serialization down to SQL, right? And because why? Developers are like customer.first name, customer.last name, like dot save, like that's it. Like whatever the object is, like I'll just hydrate it if I need to, but that's it. And then we were like going, well, it's great for the developers, and then we got these analysts, and they're not comp sci people, they're not developers, and we got to give them a way to access this, and we're like, oh crap, I mean, like, how are we going to explain objects to someone who doesn't program?
Yeah. But then ORMs are kind of a good compromise, right?
Yeah, I would say ORMs is a okay, so this may be controversial, but this is the thinking in Mongo, right?
Yeah.
The thinking in Mongo. So I'm going to take off and wear a different hat. Mongo says, like, look, if SQL won the information wars, why aren't we just transferring SQL across the wire? We tried it with XML. We tried it with a whole bunch, COBOL copybooks. We tried all this, and eventually JSON won. So if JSON is the best way to send data from one system to another, why can't we serialize that straight in the system? Why do we have to go and translate from one to the other? Like we talk JSON, and then we serialize it in SQL. That's like saying I talk French, but then I'm going to serialize it in Spanish, right? And you're always doing this translation back and forth, right? And this was the pitch. They say the pitch is data that is stored together, or data that is accessed together or stored together, right? And the idea being is that if it's JSON, you should just use one JSON all the way. And they asked this in with like the mean stack. Like it was like you're gonna go node nodes, node only nodes, JSON, node sends everything as JSON, Mongo stores everything as JSON, right? So you with the browser, you can just code the entire way through instead of these guys that are like Java this to C++ that to like some database, whatever it is, right? And to be honest, it resonates with a certain set of developers, right?
Yeah.
Right?
Yeah.
There's a lot of simplification to it, right? And so, I totally get that, but the reality of it is that data is very sticky and it's very tough, right? And meaning that, SQL is developed in late 60s, early 70s, right? And the thing is that you look over time is that it's adapted itself. It's like the C++. It just
Like
keeps on,
Fortran.
or Java. It just keeps
Fortran.
on like, yeah, it just keeps on adding and adding new, like the best ideas of every single database engine generation in the 90s, the 2000s, 20s. The SQL people have borrowed, with the database engines, borrowed all the ideas. Oh, Spark does parallelism? Okay, we're going to get parallelism on databases. We're going to, whatever it is, right? They stole their best ideas and then made it as part of another SQL database, right? So because of this, you can argue that maybe we're Frankenstein, but I like to think of it as more like we've like kind of like patched and patched and patched, and then for good or for bad, we get all these SQL dialects.
Yeah.
But
Yeah,
for
no,
the
that's
most part,
yeah.
it is kind of like it's essentially still the 1960s, early 70s language.
The analogy. So I love SQL, and I always say that SQL is like sharks. Sharks, they've been around for a really, really long time. Like sharks, they existed before trees existed, so they were like swimming in the oceans. There were no trees. No trees had been invented yet, and they're actually older than the rings of Saturn. Like before the rings of Saturn formed, they were already sharks.
Yeah, they're old. They're 4 times older than the North Star Polaris. I recently learned.
Yeah, yeah, and they're around because they're really good at what they do. That's why they are so old, and that's why they have changed very little. Because they're really good at what they do. They make no sound, and they can smell blood from miles. And I think SQL is the same. It's like it's old, but it's still around because it's really good at what it does. It's declarative. You don't have to specify the steps. You just say this is what I want, and then you get the data.
Yeah. Speaking of being really good at what we do, what we are here to do is get people to use these things. So let's take a minute and talk about one of our recent little breakthroughs that, obviously we work with the Superset program project and work on preset. And recently we pushed out the driver for people to just very easy peasy connect to CelerData and StarRocks with preset. The driver is built in. So if you're a preset customer, you can connect automatically. But Albert, I was wondering if you'd want to tell folks how they can most easily try out or connect to StarRocks and give things a test run.
Yeah, so thank you, Evan. So feel free to go to starrocks.io. You can get our operator and our Linux binaries there if you want to. Or we have is a free developer tier on cloud.celerdata.com. And it'll provision out the service for you from that standpoint. You just have to pay for the VMs, but there's no enterprise cost. There's no software cost from that standpoint. And then that with preset, you're good to go, right? And you should be able to start loading data and make those queries and joins, and no more denormalization.
Yep. And I've tried it myself. Albert and I did this a little bit together. And by the way, thanks for presenting at OSACon. That was really great. Appreciated that. But yeah, it's pretty straightforward. So I highly recommend people give it a try. And I think there's a new version of StarRocks as well that just came out. I believe I saw you posting about that. What's new or what's on the roadmap that you're excited about?
Yeah, so it's 3.2. So there's a bunch of different features from that standpoint. So with this feature, it's a lot of quality of life enhancements. So better ways, easier ways for you to load data and unload data from our system. This is the pipes and file system. We also do a lot of other things that's more like automatic bucketing, recommendation for us to go and do some partitioning and whatnot, right? So this, as the 3 spec goes on, we're really focused around several key things. So number 1 is more core data warehouse features. Number 2 is that we want to be the fastest query engine for data lakehouse products, right? And then number 3 is that this separation of compute and storage, which we call a shared data architecture, right? We're enhancing that more and more with additional capabilities, right? So that you get more value out of the product.
Yeah, fantastic. Thanks. And just checking in for a second, how are your beers? We haven't talked about that much.
It's very creamy. You guys got to try this. You got to try it. So this is like really popular. If you go to Angels game, this brewery is like a couple miles away, and it is packed, right? And so if you guys ever come down to Southern California, right? So there's 2 locations, but I think they have this one, and they have another one is a pina colada, which is with aged rum,
Oh wow.
like a year and a half, I think, or 2 years, and they sell it by the can.
Okay, interesting. I have very mixed feelings about the milkshake IPA thing. It's weird. It's strange to me, as you know. I don't know, lactose in IPAs. It's a thing, but I don't know if it's my thing. But then this probably isn't everybody's cup of tea either. This is one of those high octane ones that not everybody loves.
So you said that's a quad?
Yeah. So I don't know what the ABV is on this thing.
Well, yeah. What's the?
Let's see. Oh, it's 10.2. It's not crazy.
Okay.
But you know, formidable. But
yeah,
it's quite delicious. It's too bad we're not going to be any more of it.
Evan, I gotta get you both. Is send you guys the pina colada, because it's 16.
Okay,
wow.
Yeah. I'm into that.
Yeah. Yeah, mine is I think 8.2. 8.2. I'm on my second one. Because it's very small.
I really do enjoy the high octane ones. There's a couple of crazy ones out there that are like north of 60%, but they're still technically beer. It's kind of crazy.
Yeah, I think the most alcoholic one is the Tactical Nuclear Penguin, right?
Yeah, that was. I don't know if they still make that thing or not. But then like
it was like 33% or something.
Yeah, something like that. And then the Sam Adams Utopias ones are up in that range too. And
oh, really? Sam Adams has one?
Yeah. And there's a whole lot of people that are playing around with this ice distillation thing where you basically freeze the beer and knock the water off and do it again and again and again. Anyway, fun stuff. I should bring it up to this other segment that we talked about before. I don't know if you happen to have this thing, Albert, but maybe we could do the first iteration of the "What's on Your Desk" segment.
Oh, yeah. So one of the things that I have that I cherish is, I'm not sure if you've ever seen this.
I've never seen one in person, but I saw them on the internet a long time ago, like the 90s internet. And yeah, that's so cool. Explain.
So this is the Kurta, right? And it was developed by someone that was in the camps in Europe in World War II, right? So he dreamed about them in his head, and eventually it was the idea was a mechanical calculator. And actually, if you see the back of this, it actually says made in Liechtenstein.
Mm-hmm.
This model itself, I actually have 2 models. I have the older one and the newer one. So this is built in the 60s, and up until the digital watch, this was the most sophisticated calculator you can buy in the entire world. And people would use this in rally racing. They would do this was the iPhone, right? So when you wanted to go do plus minus multiplication divide, you carry this around, and you flip up these switches. So what happens here is there's various numbers, right?
Yeah.
And so if you wanted 1, so this shows up as 1, you actually turn the top of this and it increments 1. And then if you flip it around and you put in another number and then flip it around, that does the minus, right? And to do multiplication is that you just wind it X amount of times from that standpoint. And divide it, you would also
that's awesome.
do it a different X amount, a Y amount of times. But there is
So why are some switches red, some are black?
Yeah, we need a demo, clearly.
Yeah. So that was actually for the so every 3 is a red one. And so that way you can go and see the positions of the numbers from that standpoint. And this down here is also to help kind of with positioning. So if you wanted to say I was doing in like in thousands, right? So that you know that this is the thousandth
I see.
position and whatnot, right? So because at the end, it's just relative. Everything is just relative to each other. So we start from just zero, then we just figure that the first one is just single digits, ones, and then tens, and then hundreds, right? But what's interesting is that these need to be serviced. There's only one person in the United States that does service it today, right? And because these are not made anymore since the 60s, the guy is a watchmaker and he has to build the part. So if you bent one of the rods, you gotta go and basically this guy has to go and melt metal and bend into the right shape and then put it back all together. And there's a guy who built a 3D model of this, so you can download it off the internet, and it has an insane amount of parts into it.
Is it the same size or is it like bigger?
It's bigger, right? So
okay,
this just to give you an idea, this is kind of like the size. You're talking about like maybe 4 inches, right?
It's like a coffee grinder, basically.
Yeah, it's like a coffee grinder. They actually call some people call it a pineapple, some people call it a grenade. And so you think about it, this was all dreamt up in someone's mind, right? I mean, the guy had to be thinking of just, if you take it apart, all it is a bunch of different springs, gears, and very, very smart ways of notches to go and make sure that you're actually counting.
Can you do me a favor? And I don't know, maybe some simple calculation or something trivial, but I'm curious what it sounds like if you actually run it. I don't know if you could put it by the mic.
Yeah, so if you turn around, it actually you can kind of hear it grind its gears. And see, here's the top that actually has the numbers, right? And so you can see the numbers keep on moving on up. But it sounds very much like a old-timey watch. It's like when you push it around, you can hear the gears all grinding to get to the next spot, and it'll stop in various sequences. And if you've ever seen, there's another thing I have, which is the modern, which is a different one. Have you guys ever seen this?
No.
Turning tumble. So it's a guy who basically using marbles, you can build a binary computer. Right?
Nice.
And so the idea here is that every marble only has, on and off, right? And so you use these little drop-ins to basically say, okay, like you add one marble, it's at 0. If you add another marble, it'll set it to 1, but the marble drops, right?
Okay.
So you can buy this. I was actually on the Kickstarter for this. That's why I got this.
Oh, nice. Yeah.
But he sells it now as something like you can get off of Amazon nowadays. But it's really, really cool because I was trying to explain to my kids like how the world would be if you're base 2, and like you're like going like, how do you get to another number? And you're like, well, like, you know what I mean? It's something you have to draw. You have to get kind of like I'm a tactile guy, and it's really hard for you to kind of like visualize like, oh, like, okay, so 1 is like this number and 10 is this number, right?
You'd be able to count a lot higher on your fingers if we lived in that world.
Yeah.
Very cool. Well, thanks for sharing that. I think we should probably wrap it up in a moment here. I don't know if Beto had any other burning questions or anything. I don't want to cut anyone off.
We could go on for hours, but
that's true.
I think this is a good point.
Yeah, I see a Shania in the background. We could talk kendo, but anyway. But anyhow, I think we should probably wrap it up and give people a means to connect with us. For us on the preset and superset side, it's best to reach out to us on the Superset Slack, which I'll stick the URL on all the relevant channels and videos and so forth. But Albert, if you want to tell people how to connect with your communities as well, that'd be great.
Yeah, just join our forums or join our Slack, and you'll get a message from me one way or another.
Fantastic. Well, thank you, Beto, and thank you, Albert, for joining us on the first episode of Designated Driver, and we definitely look forward to the next.
All right. Thank you for having me.
All right. Take care.
Yeah. Thank you.
Cheers.